This is a reassessment on the standard of forces, and the problem I chose is problem 118 of chapter 2 on page 73, and it is the coefficient of static friction between a block and a horizontal floor is 0.40, while the coefficient of kinetic friction is 0.15. Mass of the block is 5 kilograms. A horizontal force is applied to the box and slowly increased. What is the value of the applied horizontal force at the instant that the block starts to slide? What is the net force on the block after it starts to slide? So, what is the value of the applied horizontal force at the instant that the block starts to slide? That would mean that the force applied would have to equal the static friction force, which we have right here. And then the formula for the static friction force is that static friction is less than or equal to the coefficient of static friction in the normal force. As we can see from the diagram, the normal force is equal to mass times the gravitational force. So you can set them equal to each other. And then once you you need to acknowledge that the sum of the net force is 0. And then so you have force is equal to static friction force, and then you can substitute, or static friction force is equal to coefficient times normal force. You substitute the mg in for the normal force, and then you get the 0.4, which was the coefficient of static friction, the 5 kilograms, which is the mass of our box, and then 9.8 meters per second squared, which is gravity. So you plug all those in, you get your force is equal to 19.6 newtons. And so now, what is the net force on the block after it starts to slide? That would mean that we now have to take the kinetic friction force, and in order to find the net force, we would have to subtract the force minus the kinetic friction force. And so, as you can see up here, the kinetic friction equation is kinetic friction is equal to the coefficient of kinetic friction times normal force. And as we see over here, the normal force is equal to mg. So you just plug in the 0.15 because that was the coefficient of the kinetic friction force. The mass, which is 5 kilograms, and then gravity, which is 9.8 meters per second squared. And then the force, which we found over here, we plug in here. So we get 19.6 minus this math equation type thing. And then you multiply this out and you get 7.35. So then by subtracting the force and the kinetic friction force, you get the net force that is applied, and that is 12.25 newtons.